Chapter 6 is all about polynomials, right? And so we're trying to talk about higher degree polynomials than what we've looked at before. We've studied linear equations. We've studied quadratic equations. Now we're going to go on and study cubic equations, quartic equations, quintic equations, and so on. And so that's really what we're talking about. What I want you to be thinking about is the sum of two trinomials always a trinomial? We're going to look at what exactly a trinomial is, how we add it, and then go from there, okay? So, let's take a look. First of all, we need to understand what a monomial is, and hopefully you know that the prefix mono means one. Mono means one, so we're kind of saying one term. A monomial is a number, a variable, or a product of numbers and variables. So it's a number, a variable, or product of numbers and variables. Okay? And the key here is that as we're looking at these, they must have whole number exponents. The exponents on the variables must be whole numbers. Okay, so let's look at a couple examples. Yes and no. Here are some examples of yes, these are considered monomials. X to the fifth, 3x to the fourth, 17, 6x squared y squared, negative 1 xy z to the third. All of those are examples of monomials. Some things that are not monomials. What the heck is that? Some things that are not monomials include x to the negative fifth, right? Negative 5 is not a whole number, so it's not a whole number exponent. Okay? The absolute value of x. 4 raised to the x power. 3 over y. X, y, z to the negative 2. All of those are not monomials. Okay, there's reasons they're not monomials. In this case, this is this negative 5. Here, the absolute value means it's not a monomial. That x right there in the exponent keeps this from being a monomial. Here, the y in the denominator is no good. Right here, this negative 2 is an exponent. It has to be a whole number exponent. Okay? Now, when we talk about these, we can calculate the degree of monomials by adding the exponents of the variable terms. So if we look at this first one, the exponent here is 5, so the degree is 5. In the second one, the exponent is 4, so the degree is 4. In the third one, there are no variables. There are no variables in the third one, so there's no exponents to add up in the third one. So the degree of 17 is actually 0. Okay? That one's a little bit tricky. The degree of any regular old integer is 0. Okay, boy, that looks like a funny 0. Let's try that again. 0. Okay? Then, in the next one, we have a 2 on the x plus a 2 on the y, so our degree is 4. And the last one, there's a 1 on the x and a 1 on the y. We need to remember that those are there. 1 on the x, 1 on the y. So 1 plus the 3 on the z means we have a degree of 5. So we calculate degree by adding the variable exponents. Okay? So, now as we're looking at this, let's kind of extend this and talk about what a polynomial is. Okay, so I'm going to clear this because my board is terrible. And let's talk about what polynomials are. Okay, a polynomial, first and foremost, can just be a plain monomial. If mono means one, poly means more than one, or many is the actual what that means. A polynomial is a monomial, or is the sum or difference of monomials, plural, right? So more than one monomial. Monomials. Okay? I'm going to give you two examples real quick. And both of these examples are written in what's called standard form. Okay, and I'll show you what standard form is in a second. 6x squared minus 3x plus 2. It's an example. Second example. Negative 17x to the 5th plus 2x minus 7. Okay? They're written in standard form because the numbers or the values of the exponents is decreasing. So in that first example, the exponents go 2, 1, 0. And in the second one, it goes 5, 1, 0. Okay? So as we look at this, let's take a second and talk about two parts of polynomials that we sometimes need to talk about. The first is, how do we calculate the degree of a polynomial? Well, the degree of the polynomial comes from looking at all of the different monomials. And so the degree of our polynomial is equal to the highest degree of each monomial. So in this first example, 6x squared has a degree of 2, negative minus 3x is a degree of 1, and this has a degree of 0, so my degree here is 2, because that's the biggest. Then I have a degree of 5, a degree of 1, a degree of 0, so my degree of my polynomial is 5, because that's what was the biggest. Okay, so we're looking for the highest one. Then, notice that the degrees are decreasing, right? We said in standard form we want to be decreasing with our degrees. The other thing we need to talk about is the leading coefficient. And the leading coefficient is the coefficient, it's essentially leading the way. It's the first coefficient, but it's the coefficient on the highest degree monomial, or highest degree term. So our leading coefficient up here, and the first one, leading coefficient is 6, and the second one, leading coefficient is negative 17. Those terms have the highest degree, so we use their coefficient as our leading coefficient, part of writing it in standard form. Okay? Now, when we talk about polynomials, there's some ways we can classify them, and that's what I want to take a look at next real quick. So, we can classify polynomials two ways, and so they get two-word names, like almost like a first name and a last name. They are classified by their degree, that word comes first, and their number of terms. That word comes second. Okay? So when we say degree, there are specific words we use depending on what the degree is. Okay? If we have a constant polynomial, that means our degree is 0. Okay? If it is a linear polynomial, our degree is 1. Write a line. Y equals x. X has a degree of 1 because it has an exponent of 1. Quadratic. Starting to have some very familiar words here. Quadratic has a degree of 2. X squared. Cubic. Cubic has a degree of 3, x to the third. Quartic. Like that prefix quart means 4. This has a degree of 4. Quintic has a degree of 5. Okay, so degree of 4, degree of 5. Those are maybe some new ones. You've probably heard 0, 1, 2, and 3. But those other ones might be a little bit new. Good thing they're awesome words. Then we can also classify based on the number of terms. We've already talked about that. If we just have one term, that's called a monomial. If we have 0 terms, why are we even bothering to look at it? That doesn't make any sense. One term, monomial. 2 terms, binomial. Bi means 2. 3 terms. Trinomial. Tri means 3. Once we get to 4 or more, we call that just a regular polynomial. So if we get to 4 or more, we have a regular polynomial. So I'm just going to give you a quick example. Let's say I wanted to write a cubic binomial. Let's say I just picked those 2 words. Well, an example of a cubic binomial, I for sure need to have an x to the 3rd term. And I'm going to make it 6x to the 3rd. I don't really care why. Then, because it's cubic, my highest term has to be, or my highest degree monomial has to be that 3. So my choices for my second term, right, binomial, 2 terms, my choices are an x squared, x to the 1st, or plain old whatever. So I'm just going to say 6x like that. 6x to the 3rd minus 6x. 2 terms, degree of 3, that is a cubic binomial. So just a quick example for you. Okay. Now we're actually going to do some stuff with these. So I want to take a second, I want to talk about how to add or subtract these. To add or subtract polynomials, what we do is we look at collecting our like terms. It's all about, can you collect like terms? Now, when you are subtracting, you also have to remember to distribute. It's a lot like when we were adding or subtracting, what's the word I'm looking for? When we were adding or subtracting complex numbers. Okay. So let's look at 2 examples. Example number 1. Example number 1 says negative 36x squared plus 6x minus 11 plus 6x squared plus 16x to the 3rd minus 5. Now, we're going to just straight up collect our like terms. So, let's see if we can figure out what our like terms are here. I have a 36x squared and I have a 6x squared. Those are like terms. That makes negative 30x squared. I have a positive 6x. Nowhere else do I have a plus 6x, so we're just going to leave it as plus 6x. Excuse me, nowhere else do I have an x term. Minus 11, minus 5. Minus 11 minus 5, that's going to be minus 16. Plus 16x to the 3rd doesn't have anything, but we still need to include it. So this is added. Now this is not added well because we would normally write it in terms of standard form where our degree decreases. 3, 2, 1, blast off, right? Or 3, 2, 1, 0. This is a cubic polynomial. Let's take a quick second and talk about subtracting, and then I want you to try. Okay, so quick conversation about subtraction. Let's see. Okay. So the first thing we want to do is we want to distribute this negative in to both of those right there. So really what we have here is 6x squared plus 4x plus 2 plus 3x squared plus 2x. Minus, 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 minus 2x. Okay? So, as you look at these real quick, now let's collect our like terms. 6x squared matches up with 3x squared. That's 9x squared. 4x minus 2x. It's going to be a plus 2x when we collect those. Plus 2. So our answer is 9x squared plus 2x plus 2. Now, really quickly, I want you to try 2 on your own. Ready? Here they are. So I want you to do the same thing we were just doing. Take a look at these. Add or subtract. Make sure it's in standard form. And then classify. You're going to give it a 2-word name. Remember, standard form means decreasing degree. Okay, so be very careful with that. Ready? You give it a try, and then let's check it. Check your work. How'd you do? First one should have been pretty easy, except for that it should have minus 3x. Oh yeah, so minus 3x plus 6x, make that plus 3x right there, and then plus 11. And that second one, I hope you remembered to do the distributive property. Now, unfortunately, these are both quadratic trinomials. I'm sorry, that got a little bit boring. But I hope you can add them, because we're going to keep practicing with that, okay?